Welcome to the Order Picking Database video module. In this video module, I'm going to briefly introduce the problem and go through the entity relationship diagram. This we've already actually covered in class and in another video, but I'm going to briefly go over it so this makes this sort of a standalone video. Then I will build the schema, the database schema, using the MySQL Workbench. So we actually want to take the the entity relationship diagram and construct the database, and then we'll run a few sample queries just to demonstrate how the database works. And so we're going to assume that we have a set of data. So here's some sample data. You can see that this is order picking data, where I have an order number, I have a warehouse where the order was picked, I have a date that the order was made, some customer information, the customer name and email, and then item information. So I have the SKU number, SKU description, the size of the SKU, the weight of the SKU, the quantity of that SKU that are in this order, and the pack date. Just as a note, the data that we're looking at is kind of a mix of real data and artificial data. So the real component of the data is the order number and the SKU SKUs that comprise the order. And so this gives us the actual order structure from an e-commerce warehouse. Also, the warehouse is real also. Obviously, the customer names are fake. You can see I am fake for all of the email addresses. And so these are randomly generated names and customer information. We also have randomly generated, well, not random, but we just have generic SKU descriptions because we didn't have that data. The size, weight, and quantity are also randomly generated. So what the real component of the data gives us is the structure between orders and SKUs. And so we get SKU demand, we get order size, and that kind of stuff is real information, and the rest is artificial. So we have three different classifications of information in our data set. We have order information, where we have the order number and the warehouse and the order date. We have customer information, where in this case we have the customer name and email. And we have SKU information, which is the SKU, the description, the size, weight, how many you picked, and then the pack date. And so the corresponding ER diagram that we have here is as follows. We have an order table, a customer table, and a SKU table representing those three pieces of information. And finally, we have a line item table which joins the orders and SKUs. And so this implements our M to N relationship between orders and SKUs by having this intermediate table. And so you can see the order table has a primary key of order num, customer table has a primary key of customer num, SKU has a primary key of SKU. The line items, which connects the orders and the SKUs, has two foreign keys. The foreign key is the order num from the order table, the SKU from the SKU table, and so that provides the connection. And then we have the quantity picked and the pack date in the date that the item was packed into the order. And so that corresponds to, if you go back to our process for converting an ER diagram to a table structure, what I have shown here is just the key structure. I don't have all of the fields that are shown in the ER diagram, but we have an order table with the primary key. It also has a foreign key for the customer number, so that's the relationship between customers and orders. The customer table, I've already said, has the primary key of customer number. SKU has a primary key of SKU, all of the other fields obviously. And then, as I mentioned, the line item table connects the SKU table with the orders table. So we have the order num as a foreign key, primary key, and SKU as a foreign key, primary key also. So now that we have the ER diagram and the table structure, what we want to do is I want to open MySQL Workbench, and we'll actually go through the process of creating this database in MySQL. And so I'm going to connect to my local instance of MySQL. First step, connect to the database. You can see I've already actually done this. Here's my order picking database right here. But I'm going to go through the process of constructing it from scratch. So the first thing I'm going to do is I'm going to open a new model. So I'm going to do this with the modeling process. And so when you do that, you can see that we now have this MySQL model here in addition to the local instance. And so I'm just going to leave the database named MyDB, but if you wanted to change that, this is how you would do it. You would edit the schema and then name the database schema whatever you wanted. Since I already actually have this database, I'm not going to overwrite mine. This is also the place where you would modify the user role. So if you wanted to add a specific user, like if you wanted to add a dedicated user account for this database schema, this is where you would do it. So you could just click on Add User, and the model then would contain the user information and then would generate the code, generate the creation code and the privilege code to add that user. We're not going to do that for this database, but this is something you should definitely explore. So I'm going to build the database using the ER diagram option. So I'm just going to click on Add Diagram here. Let's see here. There's my ER diagram. And so the ER diagram lets me build in a graphical environment the ER diagram and specify the corresponding table structure that we need. So the first step that I'm going to do is I'm going to add a table. So click over here on the diagram on Add Table, and then I'm going to place my new table here on the diagram. So the first table we add, let's do the orders table first. So again, double click on that and then edit. So I'm going to add the orders table. And then I can add the corresponding fields. So the first field that I'm going to add is the key field, the primary key, which is order number, order num. And then we have to specify the type of the field. And so this is a varchar 25. And so that means I have a character string of length up to 25 specified as my primary key, and then automatically the not null. The next field that we had was warehouse. And so to see these fields, again, you can refer back to the ER diagram that I had in the PowerPoint. But we have a varchar, this is varchar 10. So there's my varchar 10. And then finally we had the order date. And that's type date time. Let me get rid of that last one, so delete the selected. And so now we have order number, warehouse, and order date. And if we go back to our ER diagram, here's our order number, warehouse, and order date. Note that I'm not going to put the customer number in quite yet, because this customer number field is going to be automatically populated when I place this relationship. So basically, the first part of our order table is done. So the next step that we're going to do is add the customer table. So let's add our customer table right here. As before, I just double click on it to open the edit, the table edit. And we add the key column, customer num, and customer number is int size 11, so an 11-byte integer. Given name varchar 50. Family name, varchar 50 also. And finally, email varchar 100. And so here is our customer table. You can see customer number is our primary key, given name, family name, and then email. Okay, so now that we have our two tables, we want to encode or put in the relationship that says that the customer number is a foreign key in the order table. So this implements the one-to-n relationship that says each order has one customer, but each customer can have multiple orders. And so to do this, this is a non-identifying relationship because the order table is a strong entity. So I'm just going to click on that value, or click on that icon, non-identifying one-to-n. Then I'm going to click on the order table, move over and click on the customer table, and you can see that MySQL Workbench put the relationship in and automatically populated the orders table with a foreign key corresponding to the customer number. And so I'm going to just edit this because by the MySQL convention or the Workbench convention, it prepended the field name with the table name, so customer underscore, and then use the field name that I used. I'd rather just have the field name itself so that I can use that in a join statement. And so you can now see that we have the order table, the customer table, and then that non-identifying one-to-n relationship between customers and orders. Next step, let's create the SKU table. So go back to our ER diagram. So we're going to create the SKU table, which has SKU as primary key, and then description, length, width, height, weight, and price. So as before, I'm going to click on the table, create a new table, and then double click so that I can edit that. This is going to be my SKUs table. So my primary key here is SKU, and my SKU is a varchar 25. Then I have description. This is varchar, let's go to 100. Then I have my size, so it's length. Length is a int 11. Width, also an int 11. Height, int 11. Weight, we'll do as a float. And price is also a float. Oops, let me get rid of this column that I just added. There we go. And so now you can look at our SKU table and see that we have the primary key varchar 25 SKU, and then we have the description, length, width, height, weight, float. Now the choice of using the integer values for length, width, and height I made that decision by looking at the data, and the size information was given in integer inches, and so I chose to do that, whereas the weight and price were both given as floating points. So that's where those data types come from. So lastly, we will create our line item table. So we just click on new table and add that. And then I'm going to edit that and do line item. Now our line item table is a weak entity. Go back to our ER diagram. This is a weak entity that's defined by the corresponding SKU and order number. And so we are going to this time use, instead of the non-identifying relationship like we did for the customer and orders, we're going to use a one-to-n identifying relationship. So I click on that, then I'm going to click on line item and go to SKU. And you can see that as before, the Workbench added the SKU primary key from the SKU table as a foreign key, also part of the primary key component. And then we will do the same thing, go from line item to orders, and now we have that three-table relationship that implements the M to N relationship between SKUs and orders. So now I can go and edit the names just as we did before. So let me just go delete the table name underscore so that I can use just the field names. And then we need to add our two new fields, which is quantity, QTY, integer 11, and then the pack date, which is a date time. And then we don't want that last field. And so let me see here. Let me clean this up just a little bit. So now we can go back and modify to get it to look right. Got to have the line straight. Maybe if I can make that happen. There we go on that one. And then one more here. Need a better mouse. There we go. All right. So now we have our ER diagram implemented, and so we have the primary keys and foreign keys and relationships all defined. So my model now includes, let's save this. Let's save that, my new model here. Oops, my ER diagram, save my MySQL model. I need to save that. Let's just do sample. You can see I already have order picking already defined, but we're going to do sample here. And so there we go. Now we have our model, which includes, as I said, the schema, MyDB, and the ER diagram that defines our structure. So the next step that we want to do is we want to create the database. So I'm going to go to the database option and do forward engineer the database. So now we have a dialog box that says, okay, well, I need a connection. How do you want to connect to the MySQL server? And so I'm just going to use the local instance. As I said, I'm going to use the root, but if you want to have a separate user, this is how you would do that. So we would go and do that. And so now we have several different options. I'm going to skip the creation of the foreign keys. I discussed this in class about why why sometimes you don't want to create the foreign keys has to do with inserting and deleting, so we're just going to do that. I'm going to generate the index statements. I'm going to do inserts. I'm going to disable foreign key checks. Again, has to do with that foreign key constraint. Then I'm going to add a drop objects before each create, generate a drop schema. So I'm going to do that so that I can recreate the database if I if I want to make modifications in the future. And so now, when I click, it's going to say, okay, I'm going to create 4 tables. If I wanted to create views and routines and all of that, or if I wanted to create users, I would also have those options too. And this is definitely something you should give a try. You should give this give the create user a try so that you can see how that actually works. So when I say next, then MySQL then shows me the code that we use to generate the table. And so here is the code that was generated, and you can see that we have the create the schema if it doesn't exist, then use the schema, then create the tables, and here are the drop tables that I mentioned, the field structure that we define. And this is also, if we wanted to, we could save this to a file if we wanted to use this in the future, or to use this externally to the workbench. So we could, if we save this to a script file, we could create the database from the script without going through the workbench. But this time I'm just going to click next, and you can see that it connected to the database, executed the script successfully. So now I'm going to close that. So now I'm going to go back and look at my local instance, and I've got to refresh here. And there is my DB right here. And so now you can see that it has gone through and constructed the database as we specified in the model. So if we look at the tables, so if I go to customers and look at it, of course they're empty because we haven't added any data yet. They're totally, it just creates the empty tables is what we did with the model. But I said I wanted to demonstrate a couple of queries, so I'm just going to switch over to the order picking database. It's the exact same database. It's the exact same structure that we just built, except this version has some data. And so I'm going to just show this one query that I generated. And so this is I'm selecting the order information, the customer information, the SKU information from by joining the 4 tables. And so if you go back to our presentation, this is in fact the query of our database that generated this data set. So we have order number, warehouse, order date, and so on. And you can see that is exactly what this query generates. So if I execute the query, there you go. That generates the data set that we just had. So what we did in the video was we basically took the order data, which is in this single record format where we have the redundant information on customers. So, again, obviously this one order 41 has 3 different line items, and so there's no need to replicate all this information, and that was the mechanism, or that's the rationale for creating the database, which separates the information into the individual tables. Once we did that, we then talked a little bit about the ER diagram. Didn't spend a lot of time on that because we'd already done that in a previous video and in class. And the primary motivation of this video was to then implement the database using the MySQL Workbench. As I mentioned before, there's no need when you're creating a database to use the Workbench if you don't want to. You could create the script by hand. So I could create that same creation script by any mechanism, and I could use that to create the database. The MySQL Workbench just provides a nice front end and provides some help. And now when I save this model, I can come back in and open it and edit it. If I decide I want to add another field or I want to add another table, I can add that to the model and then go through and then recreate the database. So it's a fairly useful tool for this type of manipulation of MySQL databases.